Okay, I won't spend too long on this because we actually did this one in class, but to measure these things, what do we need to do? First step, measure mass on top pan balance. Guys, what you're doing, a few of you, you're saying measure the mass, but you're not saying how. How do you measure the mass? You measure it on a top pan balance. You've got to state the equipment. So the method for doing this, it includes the equipment that you're going to use. So that's the first thing to do. Okay, so for the cube, so measure height, width, and depth. What with? With a ruler. Volume equals height times width times depth. Okay, so that's enough. That's sufficient. That tells you how to calculate the volume. You can measure it directly, and that's easy. Now for the statue. Okay. Immerse in water in a Eureka can. Measure volume of displaced water. And you would do that using a measuring cylinder. So now we've got the mass for both up here. We've got the volume of the cube, we've got the volume of the statue. And then finally we have to say how you would calculate. Remember up here it says calculate, and then density is mass divided by volume. So let's have a look. We've got mark number 1, mark number 2, mark number 3, mark number 4, mark number 5, and mark number 6. So that's pretty much how it broke down. For the most part, this was done well. Guys, remember though, you don't need to write loads and loads and loads for these things. Bullet points is fine. I've written quite a lot there just to explain it, but you could bullet point this, and then it's clear. If you've got 6 bullet points, then that's usually going to be enough. Okay, question 5. So we've got a plane that's flying along. Let's look at the most important information. Flying at a constant velocity. So if we think about our Newton's laws, what does constant velocity mean? Constant velocity, constant height as well. This means this plane is not accelerating. That means the forces on it are balanced. So if we've got our drag and our lift, look at the direction the plane is flying, then we need a force to balance the drag, needs to be the same size, and we need a force to balance the lift, which needs to be also the same. Oops, that's not quite the same size, is it? It's not got quite enough space. That's about right. So it doesn't have to be exactly accurate. If you've got a ruler, you could measure it. Now, labelling them, this was done a bit poorly because some people wrote acceleration for this arrow here. Now, I understand why you wrote that. It's because you think, oh, well, in a car, you've got the accelerator. That's like the force to go forwards. No, it's not. You know what acceleration is. Acceleration is a change in velocity. So it's not right to say that, to label this as an acceleration. This is a force diagram. So what's the force that's keeping this plane flying forwards? What's the force pushing it forward? It's the thrust. It's the thrust. So a quick reminder, where does that thrust come from? We need Newton's third law, because let's think about what's happening. On the plane, you've got a propeller. The propeller spins around very fast. The propeller exerts a force backwards on the air. There's a force backwards on the air, and so the air exerts a force forwards on the propeller. And that's what pulls the plane forwards, okay? So that's what we call thrust. If you are pushing something backwards so that it pushes you forwards, then we call that thrust, okay? If it's on a road, we call it a driving force. Remember how a car works. A car works by pushing the road backwards. So the tyre pushes the road back, and so the road pushes the tyre forward, and that's what makes the car go forward. So this is called the thrust. It's not called the acceleration. We know the plane is not accelerating. Look, it's at constant velocity. Okay, so please do not make that mistake again. Now, what about this one? What's balancing the lift? Well, it's fairly easy. It's the weight. Okay, so the weight of the plane acting down. Okay, a small aircraft accelerated down the runway at 4 meters per second. The aircraft started from rest. That's key information. Rest reached a speed of 34. So 34 is our final speed. Our acceleration is 4. Calculate the distance the aircraft travelled. Okay, so this is where you need to go to your formula sheet. And the formula sheet is v squared u squared plus 2as. So what have we got? V, remember, is the final speed, that's 34. U is the initial speed, that's 0. Let's write down our units. A is 4 meters per second squared, that's the acceleration. And S is the distance, that's the question mark. We don't know what that is. So what do we need to do? We need to plug the numbers in. So let's do that. We're going to do 34 squared, that's v squared, equals u squared. Now u is 0, so I'll just write 0 squared just to write it in, plus 2 times the acceleration, which is 4, times the distance, which is s. I don't know what that is. So if I want to rearrange that, I'm going to have the s. So that's 0, so we could ignore that. So what we end up with, the distance is 34 squared divided by 2 times 4.0. So all I've done is from this equation, I've basically just divided by 2 times 4. Okay, so I've divided by 8. And if we do that, we get an answer of 144.5 meters. So all of that will get you 3 marks. Final mark is give your answer to 2 significant figures. Now, guys, this is a gift. This statement here is an absolute gift, because if you see that in an exam, what it means is there is an answer just for the significant figures. Yeah. So looking at the question, how many significant figures have they given us? Well, that's 2. That's 2 as well. Okay. I know this is 2 because, and the 4, I know it's 2 because if it was only 1, they would have just said 4 meters per second squared, but they didn't. They said 4.0. So that tells me that the O is significant as well. Right. So I need to give my answer to 2 significant figures, which is 140. So the reason I say it's a gift is because if you don't know, if you'd not known any of the calculation and you'd written down an answer that said there was like, just pick one out of thin air, if you'd said 540 like that, say, just as an example, then you still get that last mark because this is to 2 sig figs. Okay, so don't forget that. You've got a free mark anytime you see, give your answer to 2 significant figures, even if you can't do the calculation. Right, I think we'll pause there and go to the next one.